Okay, section 3.3 in your textbook is going to be talking about measures of relative position. We talked about in section 3.1 measures of central tendency. This was a mean, median, mode. Where is the middle of your data values? In section 3.2 we talked about the spread of the data values. Today we're talking about relative position. So where are your data values in terms of certain areas? Specifically quartiles and percentiles is what we're talking about today. So, what we're going to do is look at this first example. Find the mean and median of the data set. If I add these data values together to find the mean, oh, I have a yellow marker. That's not going to work. If I add them together, I have 1 plus 50 plus 50 plus 50 plus 50. How many data values is that? 5 data values, and it's 201. What is 201 divided by 5? Someone with a calculator. 40.2? That's the mean. What is the median? 50. Now let's look at the second data set. What is the mean for this one? 50. Add 50 together 5 times, divide by 5, you get 50. And what is the median? 50. Now let's compare the two of them together. The mean for the first one was 40.2 and the median was 50. On the second one, the mean and the median are the same value. What is the difference between our data sets? One value got changed. So which of these is more sensitive to changing data values, the mean or the median? The mean. The mean is very sensitive to a change in your data values. So if you have an error in your data entry or something like that happening, your mean is going to be very sensitive to that. But that's not necessarily going to show up in the median. So we look at a comparison of data values with each other, relative position of the data values. The 1 is very small in comparison to the 50. That relative position is very small. We want to have a way of showing that visually, and we're going to be doing what we call box and whisker plots to show that. Be able to see very quickly where all your data lies and if you have wide spreads in your data. So, to get to box and whisker plots, we need to talk about percentiles. For a whole number p, where p is between 1 and 99, and it can include both 1 and 99, the pth percentile of a distribution is a value so that p% of the data fall at or below it, and 100 minus p fall at or above it. So that's the percentiles. Example, you took an English achievement test, and your score came back and they reported you were at the 89th percentile. What percentage of scores are at or above your score? Okay, so let's answer number 2 first. What percentage are at or below it? 89%. So what percent are at or above? 100 minus 89. What is that? 11%. So 11% are at or above, 89% are at or below your score. Now, here's the question. Does this mean that your raw score was at 89%? When it came back to you, did you get 89% for your grade on that test? No. You very easily could have gotten a 99% on the test. Just 11 other percent got 100. Okay? It's your rank where you stand amongst everybody else who took the test. Now, suppose that you actually got a score of a 95% on the test. Does this necessarily mean that you scored in the 95th percentile? No. You may have scored in the 99th percentile, or you may have scored in the 2nd percentile if everybody else got 100% on the test. Right? It's a ranking. Now, herein lies the problem. A lot of schools will tell you that they want you to score in the top 15% of your class to be admitted to their program. Now, if your class was a highly motivated class, I have to tell you, my husband's class, he graduated, I think there was only about 35 students in his class, but out of that class there were 3 National Merit Scholars. That means they only missed 1 or less questions on the SAT test in his class. His ranking in that class was someplace around the 50th percentile. Highly motivated class. But if you put him in the year before him, the seniors that graduated the next year after him, his ranking in that class would have been up near the 90th percentile. Percentiles cause problems. Depends on whether you're in a class of incredibly motivated, smart people or less than motivated students. So institutions that ask you to be in a certain ranking are ranking you amongst everybody in your class. Now, the ACT gives basic scores, but it's still kind of like a ranking style score, but it's not out of a percentile ranking on it. But it's how you do in comparison to everybody else who took the test in the same year that you took it in comparison. So now you have a larger pool. You're taking some of that variability away that you would have in just a single class in a single school. But still, you have the same type of problems. If every university says all of our students are going to take this one test at the end of the year and they're going to score in the 50th percentile or higher, someone's got to score in the 50th percentile or lower across the nation for it to work. Everybody can't be in that 50th percentile or higher. Therein lies the problem with these rankings. It doesn't mean as much because it's compared to each other. Okay, quartiles. Listen, when you're looking at data sets, you want to know what is the lowest 25% of data, the middle 25%, upper 25%, and the largest 25% of your data. And so we divide these into quartiles. Quartiles are those percentiles that divide the data into fourths. The first quartile is Q1, is the 25th percentile. That means 25% of your data lies at or below Q1, 75% lies at or above Q1. This is a break point for the first 25% of the data. The second quartile is the 50th percentile, and we actually have another name for the 50th percentile. It's called your median. 50th percentile, 50% of the data is below it, 50% above, that's your median. So Q2 is not going to be shown on your calculator, but it'll be given to you as a median on your calculator. The third quartile, Q3, is the 75th percentile. 75% of the data is below Q3, 25% is above Q3. Steps to find the quartiles. You're going to do the exact same thing that we did to find the median. Order your data values. Find the median. That's your first step. Find the median. Then find the median of the first half of your data. Find the median of the second half of your data. And that gives you your quartiles. Q1 is the median of the first half of the data, not including Q2. And Q3 is the median of the second half of the data, here again, not including Q2. These steps are, oh, that didn't work well. These steps are what you're going to use if you're doing this by hand. And I'm going to show you one by hand, but you can, of course, do this all on your TI-83, TI-84 calculators. It will give you all this information. Interquartile range, this is where your middle 50% of your data lies. It lies between Q1 and Q3. So it's defined to be the difference of Q3 minus Q1. That's your interquartile range. And this is actually what some of the data values that we're actually quite concerned about are right here. Let's see if I can draw that. So what is the spread of the middle 50% of the data as your interquartile range? Your 5-number summary. 5-number summary is your lowest value or your minimum. Q1, Q2 are your median. Q3, and your maximum value. The smallest data value, your 3 quartiles, and your maximum data value is the 5-number summary. The 5-number summary is what we're going to use to make our box and whisker plots. Box and whisker plots give you a visual representation of the spread of your data. It is used to determine, okay, where is your data clustered, where is it spread out. That's what we're using them for. You're going to draw a scale, and this is very important because that scale is going to be where your values lie. So you need your 5 numbers from your 5-number summary as part of your scale here. You're going to draw the scale to include the lowest and highest data values. And then to the right of the scale, draw a box from Q1 to Q3. That's your interquartile range. 50% of your data lies there. Include a solid line through the box at the median, and then draw the vertical lines for the whiskers that join it to the minimum and maximum points. On your TI-83 calculators, your minimum value is called min-x, your maximum value is called max-x. Q1, median, and Q3 are specified on that as well. Let me show you an example. I'm going to do this one by hand, and then we'll look at it on the calculator so you get it, see it twice. It says many people consider the number of calories in an ice cream bar as important as, if not more important than, the cost. The following table contains the calories of 23 vanilla-flavored ice cream bars. Construct a box and whisker plot for the data given in the table. Notice that I have ordered this table going from left to right. So if you go down each of these rows, it's 111, 131, 147. It's getting bigger as we go. So the data is already in order. I did that on purpose. Save myself a step. With the data in order, I'm going to go through and find the median. How do I find the median? Middle. It's a middle data value. I was told that there are 23 of them. So I need to go in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11 on a row. And that means this would be the middle data value. 11 before it, 11 above it. So the middle data value is going to be Q2 is our median, 234. Now let's find Q1. That's the middle of the first set of data values, but now I remove the 234 when I'm finding the median for the first set. If you had had an even number of data values, you wouldn't have removed it because you didn't use a data value from your list. When you have an odd number of data values, you remove that median to find the median of the first half. So now I have 11 data values on the first row. What is the middle of my 11 data values? So it's this one right here, 181. 182, 1, 2, 3, 4, 5. Oh yeah, sure enough, it is 182. I can't read, evidently. Q3 is the middle of the last half of the data values. 342. And now I have to find the minimum and the maximum. What is the smallest data value and what is the largest data value? 111 is the smallest, and what's the largest? 439. Oh, 440. It's on the next line down there. I'd crossed off 234 and I just didn't even look down there anymore. Yeah, 440. So the minimum and the maximum. You can draw your box and whisker plot horizontally or vertically. It does not matter which way you draw it. I'm going to show it to you horizontally because I think that's the way WebAssign draws it. So here's my line for my scale. The smallest data value is 111, and the largest data value is going to be 440. So that's my scale on it. Now I need 182, 234, and 342. So if I think about 100, draw this, this would be about 200. This is going to be about 300. I'm going to change this to be 100 down here and 400 up here. So then 440 is just going to be a little bit beyond that. and 111 is going to be a little bit beyond that. Put dots for the minimum and maximum values. So here's the minimum value, here's the maximum value. Now I have to draw a box from Q1 to Q3. So I have to find 182. 182 is slightly smaller than 200. And 342 is going to be slightly bigger than 300. About halfway. Oh, that didn't work well. I messed up my scale. I'm trying to erase that. Yeah, it did it to me. It's going to take the whole line off, so let me put my line back on here. Okay, so 342 is almost half, a little bit less than half. So there's my 342. I'm going to draw a vertical line at 342 and 182 and draw that box. Questions on that so far? Okay, then where's our median at 234? It's about a third the way between 200 and 300. So there's our median at 234. Our last step is to draw the lines going out to the dots. There's our box and whisker plot. Now before I show you how to do this on your calculator, let's look at our box and whisker plot right here and see what this is telling us. We have to have a reason for doing this. Where do I have the longest region happening over here? Where is the biggest area it looks like? 234 to 342. 342 to 440 is about 100, just slightly less. But 234 to 342 is going to be more than 100. So this is where your data is most spread out. When you look at that, you can visualize that. It's a big area. So most spread out here between the median and Q3. Where is it most clustered? Where is the lines or the regions smallest? 182 to 234. This is the most clustered. Remember, it's 25% of your data in each one of these regions. So this one, the 25% is squished in here. And this one, the 25% is spread out. You guys see that? That's the visualization. That's what's happening here. Over here in this small region, this is where your data is clustered. Everything is squished together. So if you were talking about these ice cream bars, where does it look like the middle 25%, that lowest 25%, not down here, but the second set of 25%, is fairly close together. So 25% of your data is clustered between 182 and 234. The rest of your data is relatively spread out. And if you're looking at this, the lower 50% is more clustered together than the upper 50%. The upper 50% has some wider spread out data. This is a way for us to visualize our data. It tells us the behavior of our data without actually looking at all of the data. If you're writing a report and you're going to be doing this for the end of the semester project, you're actually going to be putting this on a poster. There's programs that will allow you to make a poster. You're not going to print the poster off, you're just going to submit the poster file. But you're going to give me the box and whisker plot. You're not going to give me all the data. The data doesn't make sense to the person reading it, but they want to see that box and whisker plot. So that's what you would give with all that data. So let's write down what this means. This would be clustered between 182 and 234 and spread out between 234 and 342. We want to know where is it most clustered and where is it most spread out. Okay, now what you want to know is for me to show you how to do this on the calculator, which I really don't have to do because you know where all this information is. But let me put the calculator up. Okay, go to Stat. You have to put your data into your list. So you're going to go to Edit. I actually did not enter the data into the list this time. So, yeah, if you have it, yeah, go ahead and read it to me. I know the first one's 111.
Okay, it's 111.
Except just a minute, that didn't. This is a pain to type it in on using this pen. Okay, 111, 131,
147, 151, 151, 182, 182, 190, 201, 209, 234, 286, 294, 295, 317, 319, 322, 353, 377, 377, 439, 440.
yeah, that's it. Okay, so then exit your list, and now you want to go to your Stat, Calc, one variable statistics. If you didn't put it in your list one, then you have to type in the list name at this point. I put it in list one, so we're good. And it will calculate it for you. The mean, well, the minimum is right here. Notice it says min x and Q1, both right there. And then if we scroll down, it gives you the median, which is Q2, Q3, and the maximum. So it gives you all that information that you need, and you just have to draw the box and whisker plot, which is exactly what I showed you guys how to draw. Any questions on how to do that on your calculator? We good with that? So, let's go to our classwork problem. Go ahead and get a piece of paper out. Make sure you put your name at the top of the paper. This data is also in order, so if you don't want to use a calculator, you don't have to. I need two screens, like, let's slide it. Yeah.
Really
So there's two different clusters. Compare your answers with each other, guys. Everybody should have the same answers. On the aisle, and then we'll be happy. Compare your answers. Okay guys, let's talk about the next part of our project. This project has 3 parts to it. You've done the first part, which was just some measurements. I'm calling this part 1 because this is part 1 of our analysis of the project, our data analysis. We collected the data. And so we're going to go look at E-class for the instructions port. This is due by 10 p.m. February 6th. And if you look on your syllabus, 10 p.m. February 6th is the evening of our first review, and you'll see that it says Project Part 1 in bold. That's to remind you that it's due by 10 p.m. that night. That is the due date for this. After that, it's going to start deducting 20% per class period that is not turned in for the score that you get. However, not actually turning this part of the project in and the next part of the project gets you an F in the course, irrespective of the grade you have. And yes, I did give an F to someone last semester who otherwise had a B in the class. So, do the project. We have to have the project for the Gen Ed assessment of this class. It's requested for the Gen Ed assessment. This is your incentive to do it. However, not doing a good job on the project won't kill you as long as you do the project. I just need to know that you're doing the project. So let's go look at the instructions for doing this project. They're not that difficult, really. Let me go to eClass. Appears like I just have YouTube videos up. Oh no, here's eClass. Let's go to eClass. Okay, if you scroll down the page on eClass, you'll see the class project. You'll notice that here for the class project, the Excel data file is what you put all the data in. That's where our data is. And then this is project part 1. If you click on this link, it will take you to where you're going to submit your file, and you're going to give me one PDF file of this information. Don't give me 10 files. I want one file. You can make it a PDF, you can make it a docx, you can make it an Excel file, whatever you want, as long as it's one file. Okay? I don't want 10 different files, just one file. Notice this link right here is for instructions for this part. Then we have an online histogram maker. That's because you're going to be making histograms. And I don't want a hand sketch of a histogram with a picture taken by your cell phone. I want something that looks professional quality. So you're going to go to this link for the online histogram maker, and you're going to grab the data from the Excel spreadsheet, and you're going to copy and paste it into the online histogram maker, and it's going to make the histograms for you. You are going to save those pictures that it gives you onto a document. And make sure you tell me which histogram it is, because you're going to have several different histograms. You also have an online box and whisker plot maker. Here again, grab the data, drop it into this website. It will generate the box and whisker plot for you. Copy that to your file. That's all you're going to be doing for this. So let's go look at the instructions. Here are the instructions right here for the statistics project. Let's make this bigger. It's not letting me zoom it bigger. Sorry guys, that's as big as it gets. What you're going to do, the goal is at the top of this. What we're trying to do is determine what a cubit is. Approximately, what is the length of a cubit? So we've measured a whole bunch of different arm lengths and the height of the individuals to determine if the cubit is related to the height of the individual or not. What we're going to do, something's getting ready to take off. Very high-pitched sound, I don't know what it is. Find the mean, median, and standard deviation of the arm lengths of the women. You can do this if you copy all that data onto your own Excel spreadsheet and just use the average and the STDEV, standard deviation. So you want the average, you do equals average and select, and then equals STDEV and select, and that will give you the average and the standard deviation. So that won't take you long at all. You're going to do that for the women. You're going to do the same thing for the men, for the arm length, and for the heights separately. And then you're going to come down here, you're going to create histograms. I need 6 histograms. I need histogram for men's height, women's height. a histogram for the arm length of each men and women, and then a histogram for the combined heights and combined arm lengths. So I want to know what is the basic shape of the subsets of data, what is the basic shape of all the data. That way we can get an idea of what the data looks like. We're going to do the same thing for the box and whisker plot. On these, you don't have to give me the 5-number summary, you just need to give me the box and whisker plot. So you're going to give me the 6 box and whisker plots. And then the last thing that you're going to do is going to analyze the data. Does there appear to be an overlap in the lengths of the arms of women and the lengths of the arms of men? How do you see this? You look at the spread of the box and whisker plots for the arm length for the men and the arm length for the women. Are they in approximately the same lengths? Or do the women start at, 18 inches and go to 22 inches, and guys start at 24 inches and go to 30 inches? Is there a difference, or is there some overlap? Are some of the arm lengths the same length or in the same region as each other? So if you look at the box and whisker plots in the labels underneath, you'll know whether they're approximately the same or vastly different. Compare the arm lengths. Compare the heights of the men and women. Is there an overlap? Are they approximately all the same height? Is there a difference in the spread of heights? Are the heights of the men more spread out than the heights of the women? You can see all of that from the box and whisker plots. So you're going to do that based off of the box and whisker plots. And then lastly, are there any outliers? You kind of see this looking at your histograms. Do you have a box that has just 1 or 2 elements in it and it looks bimodal or something like that? That typically indicates to you that you have something that's an outlier, something on the very far out fringes after you have an empty spot in your histogram. So that is what you're doing. That is a document I need. You're going to type it up. You're going to submit it by 10 p.m. the day of the first review. That's February 6th for our class this semester. Make sure you have that turned in. This really isn't that hard. If you use the 2 links to the websites that I gave you, you'll have that part done in about 15 minutes. Then you have to go and figure out how to answer those questions. This really shouldn't take you much more than about an hour each week.
On the 6th, on the 6th.
On the 6th by 10 p.m. After 10 p.m., it starts getting counted 20% off per class period, then it's late. Okay, we are done for today. If you have any questions on anything, let me know.